Okay, hi guys. Okay, we're going to start with the first example regarding using partial fraction for integration. So the question is integrate 3x over bracket x minus 1 bracket x plus 2 dx. Okay, as you observe, the denominator is actually a distinct linear factors, correct? So we'll be using rule 1 to break this fraction into partial fraction. So first we will say let 3x over bracket x minus 1 x plus 2 equals to a over x minus 1 plus b over x plus 2. So our next step is to find a and b. Now to find a and b, we multiply the whole equation by this denominator. Okay, so we multiply this equation by this denominator, so we will get 3x equals to a bracket x plus 2 plus b bracket x minus 1, right? Now the next step, to find a and b, we can use different values of x and sub into this equation. Now one way is to use this bracket, which is x plus 2, to find the values of x. So we set this x plus 2 equals to 0. So in this case, x will be minus 2. Then we sub x equals to minus 2 into the equation. X minus 2 into the equation. So get 3 bracket minus 2 equals to, now of course a will times 0, right? A will multiply 0 because we set x plus 2 equals 0. So a will multiply 0 plus b minus 2 minus 1. So you have minus 6 equals to minus 3b, and b will be equals to 2. So next we go to the second term and set this bracket x minus 1 equals to 0 again. Set minus 1 equals 0. So here will give us the x equals to 1. So using the same method, we sub x equals to 1. We have 3 bracket 1 equals to a 1 plus 2 plus 0, right? Because b times 0 is 0. So we can also don't write the 0. So eventually a is equals to 1. So now after finding a and b, we are ready to integrate the fraction. So we get 3x, integrate 3x bracket x minus 1 bracket x plus 2 dx equals to integrate the partial fraction of this fraction, which is 1 over x minus 1 plus 2 over x plus 2 dx. So we can break into 2 addition and integrate each individually. So plus 2 per bracket integrate x plus 2 dx. Okay, to integrate this, we can use the formula. Now what formula to use? Okay, the formula, we can use this formula. So in case it's not inside the formula list, you would like to add into a cheat sheet. So integrate 1 over ax plus b dx is equals to ln modulus ax plus b over a plus c. Okay, so by using this formula, our answer will become ln modulus x minus 1 plus 2 ln modulus x plus 2 plus c. Okay, so this is how you apply partial fraction in your integration question. So next, we will do the next example in your slide, which is repeated which has a repeated linear factors in your denominator. So you focus on the denominator, so you write 5x squared plus 20x plus 6. Now seems like there are no factors, so you have to factorize first. So you bring out x squared plus 1, right? So you bring out x, you have x squared plus 2x plus 1. So you further factorize the quadratic expression. So you get x bracket x plus 1 square. Okay, so now clearly this is your repeated linear factor, right? So to break into partial fraction, we use rule 2. Rule 2 is for repeated linear factors. So if you cannot remember, you can refer back to the previous video regarding the introduction of partial fraction. So we say let 5x squared plus 20x plus 6 over x plus 1 square equals to a over x. So this is rule 1. Rule 2 is b over x plus 1 plus c over x plus 1 square. Okay, so you can see this is the part that we use rule 2, and this is the part we use rule 1. Okay, so now you have to find ABC. So similarly, we multiply the equation with this denominator of the left fraction, of the left hand side fraction. So we multiply the whole equation with this denominator, and we will get this. We get a new equation, which is 5 squared plus 20x plus 6 equals to a bracket x plus 1 square plus b x bracket x plus 1 plus cx. So again, we focus on the first bracket of the brackets of the first term there. So we set x plus 1 square equals to 0. So x must be minus 1. Okay. Now knowing x sub x equals to minus 1, we sub x equals to minus 1. Okay, into this equation, so we get 5 minus 20 plus 6 equals to, now a will multiply 0, b also multiply 0 because of the x plus 1, then plus c will multiply minus 1. So you get c equals to 9. Now you go to the second term, you can set x equals to 0 for x. So again, we sub x equals 0 into the equation. So we get 6 equals to, now 0, a will be 1a, now b will times 0, so c will also times 0. So we get a equals to 6. So now we left with cx. Now cx will focus on x equals 0, so we get back the same value for x. So instead of, so now we can think of any other values of x to sub in. So normally we will sub in a smaller value that is easy to calculate. So values that are small and easy to calculate usually are minus 1, 0 or 1. So now I sub x equals to 1, since minus 1 and 0 already used. Okay, so I sub x equals to 1, so you will have 5 plus 20 plus 6 will be equals to a 2 square plus b 2 plus c. Okay, so since we know the values of a and c, we can sub in also. So we get 31 on the left side, 4 bracket 6 plus 2b plus 9. Okay, so you know 24 plus 9 is 33. So b will be equals to 31 minus 33 minus 2, b is minus 1. Okay, so now you already find a, b, c. So again, we can now finish the question by integrating the partial fraction of the fraction. So 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx. So we integrate a. So a we know is 6 over x plus b is minus 1 over x plus 1. c is 9, so plus 9 over x plus 1 bracket square dx. So again we split the expression into individual integration and apply the formula to integrate. Plus 9 integrate x plus 1 minus 2 dx. Okay, so applying the formula which is in your formula list, so you should get 6 ln x minus ln x plus 1 minus 9x plus 1. Okay, then minus 1 on top plus c, or you can write 6 ln modulus x minus ln x plus 1 minus 9 over x plus 1 plus c. Okay, so this is the final, so this will be the final answer for this question. Okay, so next we'll go to our next example in your slide, which is quadratic irreducible quadratic factors in the denominator. Okay, so this is the example, the third example in your slide. Now the word anti-derivatives means integrate. Okay, so integrate this. So similarly we still have to make use of partial fractions. So we say let 2x squared minus 5x plus 2 over, now x cubed plus x you can take out common factor, x squared plus 1 equals 2. Now this is your irreducible quadratic factor, means cannot be factorized. Okay, so any quadratic factor cannot be factorized will be under this category IQF. So we have the first, this is a, but x itself is linear, so it's distinct linear factor, DLF. Okay, DLF. So we follow the rule number 1, a over x plus, now because you have a irreducible quadratic factor, you have to use rule 3. So bx plus c over x squared plus 1. This is your rule 3. Okay, this is rule 3. Okay, if you forget the rule, I advise you to refer back to the previous video. Okay, so now similarly you want to find ABC, so same thing, we multiply the denominator by this. Okay, sorry, we multiply the equation by the denominator, by this denominator. Okay, we multiply the equation by this denominator, so we get 2 square minus 5x plus 2 a bracket x squared plus 1 plus x bracket b x plus c. Now this, we go to each bracket again to find the values of x to sub in. So x squared plus 1 equals to 0 has no solution, right? There's no solution. Why? Because cannot be factorized, means no solution. So no solution means you cannot find any x value. So this one, wherever you see IQF, you can ignore. Okay, ignore, just go to the next bracket. Now there's no next bracket, but there's x. So x equals 0, right? You set x equals to 0. Okay, so then we can actually continue the finding of the a, b, or c. Sub x equals to 0. So we get 2 equals to a. Right. Now, how to find b and c? Now, one way is to sub x value. Okay. Now the other way you can do is, especially for this type of question, I advise you to learn how to use comparing coefficients. So you can say by comparing coefficient of, let's say, x square. Okay, now x square, so left side you have 2. Okay, 2. Now right side, who will give you x square? A will give you x square, because a times x square will give you ax square. Then the next x square will be bx square, right? And it's plus, so there's a plus. So eventually the right side, the coefficient of x square on the right side will be a plus b. Now as you know, a is 2, so we put in 2 plus b. So of course b must be 0. Okay. To find c, we use the same technique by comparing coefficient, but this time we comparing coefficient of x. So by comparing coefficient of x, so you see the left side coefficient of x is 5, right? Minus 5. So you just put minus 5 on the left side. Now the right side, okay, you look carefully. Okay, this bracket, there's no x. You cannot have any x here. So there's a x here times c, right? So of course, that means this 2 will give you cx. That means the coefficient of x on the right side is c alone. So now we have found ABC. So we can finish the question. Finish up the question by putting in the partial fraction. Now b is 0, so no need to write, so plus minus 5 over x squared plus 1 dx. Now this same thing, you can take out the 2 to get 1 over x dx. Minus 5 you can take out, so integrate 1 over x squared plus 1 dx. Now to integrate this, okay, we have to use the formula. So what's the formula? So formula is in the formula list. Integrate 1 over 1 plus x squared dx. You get tangent inverse x plus c. Okay. So we finish up the question and write 2 ln x modulus x minus 5 tangent inverse x plus c. Okay. So I hope you finally understand, okay, how to use partial fraction to do your integration for certain types of question. Now the next 2 examples I will present it in the next video, so I will see you again, which is the last 2 examples for integration. So after that I will go into L'Hopital rule, then followed by improper integration. Okay, thank you for your attention.